Before we dive into today's episode, make sure to hit that subscribe button. It's the best way to stay updated with our latest insights.
Ladies and gentlemen, welcome to the CTSS Academy podcast. The energy is electric. The crowd is alive. Let's dive into greatness. We're champions strong.
Before we start the show, don't forget to check our new ebook, Kill All Bugs, Learn Software Testing in One Day. For a limited time, it's only $9.99. Links in description.
If you've ever gone through, the simple act of setting up a new computer and installing an external hard drive or maybe just formatting a cheap thumb drive, you eventually hit that moment where your operating system asks you to make a choice. FAT32, exFAT, or NTFS.
Right.
And for most of us, this is just total alphabet soup. We just click the default, hope for the best, and, move on.
Of course.
But that simple choice dictates everything about how your data is handled, how big your files can be, how fast you can access them, and really critically, how safe they are if your system suddenly crashes.
It does.
Okay, let's unpack this. The mission today is to take a deep dive into these foundational technologies that, they organize our entire digital lives. These file systems are the invisible infrastructure, and understanding the trade-offs between FAT32, exFAT, and NTFS is the shortcut to being well-informed about your storage.
It's the perfect deep dive because, the file system is truly the unsung hero of computing. We tend to focus on processors or RAM.
Sure, the flashy stuff.
Exactly. But the way your data is organized is arguably more crucial. Fundamentally, a file system is a sophisticated set of rules. It's algorithms and data structures.
So if I click Save on a giant photo, what is the file system actually doing?
Well, it's performing a really critical translation. When you click Save, that's a logical operation. The file system takes that logical request and figures out exactly where and how to map that information physically onto the storage medium.
Okay.
Whether that's a spinning disk or flash memory, it translates the name giantphoto.jpg into a specific address on the drive.
I often hear it described as like the librarian of the hard drive.
That's a great starting analogy. We can make it a bit more technical, but still keep it clear. The key piece is the file allocation table, or FAT.
Which gives two of our systems their names.
That's the one. This table is essentially the index card system. It tells the computer where every single piece of data, which we call a cluster, is located. Without that index, the information on the drive would just be, a single unusable mass of data.
Right. Just total digital chaos.
Exactly.
So if the core job is just organization, why do we need 3 different systems? Why not just have one super librarian?
Because the requirements of data storage have evolved so radically since the 1970s when these concepts were first developed. We're comparing a system designed for floppy disks with a system designed for multi-terabyte drives with enterprise-level security.
That's a huge leap.
It is. So today we're looking at the 3 key contenders: FAT32, the old standard; exFAT, the modern flash specialist; and NTFS, the powerful, secure Windows default.
Let's start with the granddaddy then, FAT32. This technology is decades old, dating all the way back to 1996 with Windows 95.
Where it replaced the 16-bit FAT. Its age is really its defining feature, and frankly, its greatest weakness.
And what immediately defines it for most people is that limit.
The hard limit, yes. When it was created, a 4-gigabyte hard drive was considered absolutely massive. This history is exactly why it has its primary drawback, that painful 4-gigabyte individual file size limit.
Oh, that limit. I remember that so clearly. I spent years having to split huge video files just to move them between computers.
We all did.
So where does that limitation come from architecturally?
It's hardwired right into the system's design. Specifically, it's related to that index we mentioned, the file allocation table.
Okay.
FAT32 uses what's called a 32-bit address space. This means the location markers, the entries for each cluster of data, are limited to just 4 bytes.
4 bytes, that's it?
That's it. Think of it this way. A cluster is the smallest chunk of space the file system can manage. If your cluster size is, say, 64 kilobytes, And your address marker only has enough space to point to 4 billion possible locations. Well, you quickly run out of ability to address data once you hit that 4 gigabit mark for a single file.
It's like having an old odometer that just rolls over.
Exactly. You just can't count any higher for one continuous thing.
And it's not just a single file limit. There are partition limits too, right?
Yes. While the underlying system can technically support huge physical drives, maybe up to 16 terabytes with large clusters, you can't actually create a partition larger than 8 TB using FAT32 on modern systems.
But for day-to-day use, that 4 gigabit file limit is the real killer.
Absolutely.
So given those ancient limitations, why hasn't FAT32 just been completely retired? What's the hidden superpower that keeps it relevant today?
One word. Compatibility. Pure universal compatibility. Because it's so old and so foundational, every major operating system, Windows, Mac, Linux, can read and write to it natively without any issues.
And it goes beyond computers, doesn't it?
It does. I mean, virtually all legacy or niche electronic devices,
Right.
like older digital photo frames, specialized audio equipment, car stereos, certain gaming consoles, they're all designed to expect FAT32. It's the lowest common denominator.
So if you format a drive as FAT32, you just know it's going to work.
You know, it will be recognized almost immediately by almost anything made in the last 20 years.
But that convenience comes at a severe cost. Beyond the size limits, what does it lack in terms of, I guess, modern robustness?
It lacks everything related to security and stability.
Everything.
Pretty much. FAT32 has no permission structures, no encryption, and critically, no way to reliably recover files if there's a sudden power loss. If you pull the plug while writing data to a FAT32 drive, you are very, very likely to end up with corrupted files.
Right, so we needed something that kept that FA structure, that compatibility, but just busted open those size limits.
Exactly.
And that brings us to 2006 and the introduction of exFAT, the Extended File Allocation Table.
Yes, exFAT was the direct response to that 4 gigabit frustration.
Microsoft designed it specifically as the modern high-capacity successor to FAT32. Its role is highly specialized. It's the file system optimized for flash media.
So thumb drives, SD cards, that kind of thing.
Thumb drives, SD cards, large portable hard drives, absolutely.
And the size limits are essentially gone, right? You can drop a 50 gigabit file onto an exFAT drive with no problems. Exactly. For all intents and purposes, it has no realistic file size or partition size limits that a normal person would ever hit.
And it's optimization for flash. That's not just about size, is it?
No, it's also about reducing write overhead compared to something like NTFS. Flash memory has a limited number of write cycles, and exFAT is designed to minimize all that unnecessary write activity that's associated with things like security logging.
I see. So it's actually easier on your memory's fixed lifespan. And how does it stack up against FAT32 for cross-platform use?
It's much better than NTFS. It works natively with all modern Windows versions and Mac OS X. This makes exFAT the absolute gold standard for transferring large files, like video or high-res photos, between a Mac and a PC.
And Linux.
The only caveat is that Linux users usually need to install a minor package to enable full functionality. But it's a simple step.
But we know there's always a trade-off. If exFAT solves the size problem and has great compatibility, why would anyone use anything else? I'm guessing the missing piece is that thing you keep mentioning. Journaling.
That's the critical difference. exFAT still lacks the robust, industrial-strength data protection features of NTFS, primarily journaling.
It can still recover some things, though.
It has better data recovery potential than FAT32, yes. It can sometimes restore deleted files, but it is still fragile compared to its more powerful cousin.
Which means we finally have to talk about the Windows powerhouse, NTFS New Technology File System. This debuted way back with Windows NT, but it's been the default choice for system drives since Windows XP.
And for good reason. NTFS is all about stability and security first. When you install Windows, you must use NTFS because the operating system itself relies on its advanced features to function correctly and resiliently.
Okay, let's dive into the architecture here. What exactly is journaling, and why does it make NTFS so much safer than exFAT?
So that's the defining feature. Journaling means the file system keeps an internal transaction log, a journal, or a ledger of every single change it intends to make to the drive before it actually makes the change.
Okay, so it writes down what it's about to do first.
Precisely. Imagine you're a pilot going through a pre-flight checklist. Before you execute the step of taking off, you check it off the list. If the plane loses power midway through that checklist, you know exactly where you left off.
I see.
If you lose power while writing data to an NTFS drive, the system just checks the journal upon restart. It can roll back any partially completed transactions, and that guarantees system consistency.
That's fascinating. So if exFAT is like writing directly in pen, and NTFS is like writing every change in pencil on a draft ledger first and then committing it to the final page.
That's a perfect way to put it. And that checkpoint information allows the system to restore consistency very quickly, preventing the kind of corruption that just plagues the FAT systems after a power loss.
Here's where it gets really interesting. Beyond that resilience, what other security and management capabilities does that log structure unlock?
Security is paramount. Unlike the FAT systems, NTFS allows administrators to set very granular file permissions and encryption controls.
Meaning you can restrict specific users from even seeing certain files.
Exactly. You can control who can view, who can modify, which is just non-negotiable in business and multi-user environments. It also has excellent built-in storage management features, like disk quotas.
Right, limiting how much space one user can consume.
And for saving space, it has native file and folder compression built right in, which the older systems simply don't have.
It sounds like an absolute must-have for any permanent mission-critical storage. But we know the downside is almost always compatibility. If I take my NTFS external drive and plug it into my friend's Mac, what happens?
It becomes a one-way street. Mac OS X can typically read the files from the NTFS drive, but it can't write new files or modify existing ones without installing third-party software.
And it's the same for Linux.
The same read-only limitation often applies to Linux, yes.
So why did they do that? Is it a technical limitation or more of a strategic choice?
It's a mix of both. The ability to write reliably to NTFS requires understanding and flawlessly interacting with that very complex journaling and logging structure, which is proprietary to Microsoft.
And if you get wrong?
If you get it wrong, you could destroy the data. So Mac and Linux often default to read only just for safety. They don't want to risk corrupting the drive by interacting imperfectly with that journal.
And you mentioned a performance quirk earlier, that NTFS is surprisingly slow on very small disk sizes. Why would the most advanced system stumble on the smallest tasks?
It goes back to that logging again. Every time you write, the system is managing that complex change journal, checkpointing the information, maintaining security permission.
All that overhead.
All that overhead. On a tiny drive, that management cost, the price of all that security and resilience, can actually outweigh the speed benefit of the write operation itself. It's designed for massive storage where stability is much more important than micro-performance.
That provides a huge amount of context. So we've walked through these three distinct eras of file storage, and now we really need to synthesize them. When you, the listener, open that format dialog, how should you decide?
If we connect this to the bigger picture, the decision really comes down to three factors: compatibility, file size, and resilience. And you can't have the highest level of all three at the same time. There's always a compromise.
Okay, so to summarize the core differences very clearly for the next time you have to choose. FAT32. This is the system you pick when you prioritize maximum compatibility. For old hardware, gaming consoles, specific media players, but only if you know for sure you won't exceed that strict 4 GB single file limit.
Then you have exF. It solves the large file problem. It's optimized specifically for speed and lower wear on flash media, and it works great across the major modern platforms, Windows and Mac.
It's the perfect travel drive for sharing huge files.
It is. The sacrifice here is resilience. It lacks NTFS's life-saving journaling features.
And finally, NTFS. This is the only acceptable choice for your primary system drive or any high-capacity, non-removable storage on a Windows machine. It offers the best security, superior recovery, and handles enormous files beautifully.
But you are trading away that universal plug-and-play compatibility. It's mostly a Windows-centric system.
So what does this mean for you? If you just bought a new 128 GB thumb drive and you plan to transfer high-definition video files back and forth between a Mac and a PC.
exFAT is mandatory. It's the only one that really fits. But if you are setting up an external drive that will only ever plug into your Windows desktop for nightly backups,
then NTFS is the clear, safer winner.
absolutely, because of its stability features like shadow copies and journaling.
We've seen how three systems, designed over decades, serve these vastly different needs based on their hidden limitations and advanced features. It's a powerful lesson that even the simplest choices in technology have these layers of history and trade-offs built right into them.
Indeed. The fundamental choice of file system dictates the entire utility, security, and potential lifespan of your data storage. It is the core infrastructure, and its resilience, that ability to recover consistency through logging and checkpoints, is what truly separates these systems and protects your digital life.
Absolutely fascinating. Thank you for helping us decode the invisible infrastructure that holds all our files together.
My pleasure.
So the most modern system, NTFS, offers the best resilience through logging and checkpoint information, which is critical against power failure. But since we learned that the complexity of NTFS makes it slow with very small disk sizes, the question is, are we sacrificing optimal performance on smaller media, like, say, a 16 gigabit SD card, for the sake of advanced recovery features that we might only truly need on much larger mission-critical drives? That's something for you to consider the next time you format a new drive.
Thanks for listening. If you found value in today's episode, please subscribe and leave us a review. It helps more people find the show. See you in the next one.
Hey, yo, haven't you checked out our new book yet? Link in description.